Alright, so right now I'm running a simulation of a robotic cell that I'm gonna change its original programming. The robot originally picks part from what we call a heat plate, from a in-feed slide, and then the statement tells it through this bit here. I want to turn it off so it will stop picking parts from the this bit tells it it's an input from the PLC telling you there's a part ready at the statement, and then it places the part as it is commanded in using a global interface. And right now the PLC just sends an integer value, and that value is just a 1 through a 60 integer value, and that's just the whole position. It goes just goes just goes 1 through 60. Kind of like junk there. So 1 to 10, and then 11, 21, 20, 21, 30, 31, 40, and so on until 60. But the change we're going to make is when I make the robot run different part sizes. So this is for a 13 millimeter size element. It's going to be running 3 more part types, different sizes, so the plate may look different, may have a different geometric arrangement, different hole sizes, and number of holes in X and Y. So the PLC is gonna tell which part type is gonna run, and all the grid distances are pre-stored using R registers. And then also the geometry of the plate. Part type 1 has 10 by 6, maybe the part 2 may have 8 by 5, and so on. And also the grid separation is going to be stored on a part type program, depending on what part type the PLC is set to run, which is going to be binary coded. We're going to have some sensors attached to the heat plate to instruct the PLC on what part type is going to be running. So the PLC is going to be the driver of what part type is being selected, and the robot is just going to be adapted to it. So right now I have some flag bits to signal the PLC, the robot, that there is a part present at the statement, and so on. Right now I'm going to change the position to to place, to say 2, and I'm going to keep this on. So let me just move the robot here to the visual area, and I'm going to enter 2, and then I'm going to keep changing that. 3. I want to try and zoom here so you know which holes is being. Okay, I'm going to change it to 4, so it goes to hole 4. I'm going to change it to 5. It goes to 5 and 6. Gotta go 6, 7, 8, 9. Next is gonna be 9, and I'm gonna change it to 10. And then 11, of course. So it's going to be here, the next hole. So it always goes to a bob plate, which is an opposite value at the center of the plate. And let's say I abort the program. Let's say I just go there and stop the program. Screw this. I want to abort the programs. So function abort all, and here I'm going to select again my main cycle. I'm just going to run it. So I also have a auto homing program that uses the LPUS, and then it uses some system variables to calculate the current row position versus a list of PRs. So if it's close enough to a known position, it's gonna move to that point first. And the method I use is just, you know, in Cartesian coordinates you got x, y, and z, and the distance between the magnitude, the distance between 2 points is just the square root value of x, y, and z differences squared. So in Fanuc you can buy the advanced math package, but I did it a little differently. I used a clever, a little more complicated algorithm to instead of square root, because I don't have the function. If the difference is less than 0, then I just multiply by -1, and thus I make that positive. That's what a square root will do. I mean, you square it and then you square root the value, so there's no negative of that, and thus I get the sort of like the magnitude. It's not the real magnitude per se, but it's close enough, and that's an indicator that how close am I to a point in space. So I can change that because I pass values to functions or programs as arguments. You know, you can pass arguments to a program so it can adapt to that. You can do computational functions with it. Subtract it, multiply it, move to that point, whatever. So that's what I do here. So the program was aborted, right? Let me just move the robot here so you can guys see. So I'm gonna start it now again. So robot will I'm going to show you what it's going to do here, and I'm going to go to register 55, which is going to tell me what is the closest position register is going to go to, and it found that to be found that to be position 10, and it went back. It did that really fast. It found the closest point to be PR10, which is let me get that. Data here, type, registers, position registers. PR10 is above the heat plate. So I aborted the program, and the closest point was above the heat plate, right? It was over here, like over 10 or something. It was moving there, so that is the closest point it was at. That's what it went to. Okay, so now let's just stop the picking and dropping into the heat plate. Just gonna stop that. Sensor is gonna go off. I'm gonna go to item 19, and then I'm gonna make that one here 20, which is the position in which to place a part. I'm gonna turn that to 0, meaning it's not gonna place any part. And then I'm gonna change the peak position. Okay, let's pick part 1, which has been sitting there for a while, so it's ready. So I'm going to run that. It's going to pick the part, and now it's going to place it into the calibrating station. Also, there's a standby position, so it picks a part, and also I need to tell it that the press is ready. So, like, the press is open, so it can drop a part, or maybe not. That I forgot. I need to find out which flag number that is. Item 102. So load ready, that's 106. Alright. Okay, so the load is ready. So load ready, meaning that the calibrating press is ready. It's open up, the part is ready, turn that off, and it's gonna judge the part. Now it's gonna drop the part in the reject because I need to turn the good part part okay. Oh, unload good part. So I need to turn that on, which is 107. Turn that on. Yeah, I need to turn this on again. Let me turn this on here, and right here, and then turn that on again. That the load is ready. So it gets apart, and also I need to change this here. So register data. Okay, so I'm gonna pick from position 2 now. I'm gonna abort the program whenever I like. Like, I'm gonna abort it. Let's say the part that it just picked is not good. It's not good. It's a bad part. So it's gonna reject it. I'm gonna abort. I'm gonna pick a part. Next part is gonna be aborted, I think. And the next part that picks from the press, which is that one right there. I'm gonna abort it there. So the robot. I just stopped the robot mid-cycle, so I'm gonna abort the program now, and I'm gonna reselect my main cycle again, and I'm gonna run. And I want you guys to see what position register, register 55 is. That is the index it found the PR closest to. So let me just keep a close eye on that. Let me see if I can make this larger. Display, shift, display, single. Okay, data. Item 55. Item 55. Okay, so right now it's 10. Let's run my program. And this is gonna go through a series. It's too far from a safe point, so it couldn't find one that is close enough. It's too far. So that will happen, and then you need to jog it. But let me abort the program again. So you abort the program. Select new. Function, abort the program, data, select main cycle, data, and let's run this. So it's gonna find point 10 to be the closest. So also if I go and change which position is gonna pick the parts from, let's say I want you to pick position 55. The next position is gonna pick the part from is 55. Let me see, select main cycle is load ready data. Pick position 55. Select. Oh, I know why. Because there's a part in the standby, which is data. Let me see, function, menu, IO, flag, item 100. So part at standby. Just down here. Yeah, so I need to turn that off. 1, 2, 3. Yeah, because there's a tracking I have. So I need to reset that in my auto home. So that is going to be off. That is telling it that there's a part in the standby position here. So let's see if I can get this off here. And data. Alright, so let's pick position 60 now. I'm gonna pick the part 60. That's it. If I were to abort the program now, say I aborted the program function, just abort the program, yeah, aborted. and then select again the program main cycle. Let's just run it. Cycle start. Okay, so it's gonna go and drop whatever part it's got in it. Even if it doesn't know, it's gonna open the gripper once it reaches to reject pin, and it's gonna drop the part. Now it's gonna keep doing that until I tell it, hey, you know what, there's no more parts for you to pick, 0. And I need you to go and grab a part from the escapement and place it into, say, 1. So I need to go back to 102, which is the escapement sensor, and tell it it's on, and then turn the escapement sensor on. So it's gonna go and here, gonna go and item, oops, select here, item 20, yeah, that's place position number 3. Let's try 1 again, and then I can show you what I'm talking about. So it's doing the gripper, just away instruction and all that. So far, this is how far I've got with the program. It's almost ready. I was able to get a hold of the STL file for the gripper. I drew this in AutoCAD. I'm also waiting for the final drawings for the in-feed escapement, and if I can get from the mechanical designer the STL model for the calibrating station here, it will be more helpful. Right now I don't have a lot of elements here, but as the project moves in time, I'll probably add more elements to the environment here. Well, thank you for watching, and stay tuned for more.